Hi, this is
Hello.
American College Dream, and today we have Tej from my school. He is a senior, and we will be talking about STEM. In particular, we'll be more focused on AP Physics 1 and 2. So we just had a little talk, and we say we're just going to go ahead and talking from the bigger subjects and then down to the smaller subject. And we go from AP Physics 1 and then talking about AP Physics 2. So I asked Ted to come because he enjoy asking questions and right, Ted?
Yeah, a lot of questions.
So I always get like like a three question in 1 minute from him, and so I think it's a good choice for him to ask a lot of questions, for him to answer some questions. Ted, why don't you introduce yourself briefly? Introduce
Mm,
yourself.
Yeah, I'm a senior now in Pacific Academy, Irvine. And yeah, I've been in physics for 1.5 year, physics one and two now with Dr. Jing. Yeah.
Okay. All right. So first of all, right, how do you rate Dr. Jane from 1 to 10?
Oh, well, I would I would definitely rank for like out of my teachers, probably definitely from 9 to 10 because
Okay.
he
Well,
like
don't break don't break people's heart. Okay.
the reason I'll say that is because um he really make it difficult for me to be lazy.
It's like,
So yeah, so that's my biggest
okay.
weakness.
Don't talk too much about that.
Yeah,
I did not prepare to ask him that question. It's just kind of comes out. So anyway, but thanks for that. I mean, it's good to be a tough teacher sometime, but they all hate me. I know they all hate me.
yeah.
I'm very mean teachers and and stuff like
No,
that.
no.
Give a lot of homework and drive them crazy. Okay, so second question I have is so how have you learned? How have you learned in the subject? Like
And
like
which
rate yourself 1 to 10. Do you think you have
oh
learned well?
I think I'm always like still learning stuff. So I'd say it's like an eight, about eight. Yeah.
Hmm, okay. Well, obviously, Tej did get a five in AP Physics 1, right? So he's yet to see himself in AP Physics 2. In terms of overall physics, right? So, I mean, there's so much in physics. So, in your opinion, right? If you study physics, you become good at it. I mean, why? What's the motivation of learning physics, in your opinion?
Mm,
Besides, like in a classroom, it's like let's say, just in general in life, what's the point of learning AP, physics?
yeah. To me, physics as a whole, like I can find like hundreds, even thousands of like topic where I can keep digging deeper and pretty much never stop. And they all have real life application. And as long as you're creative, it can be like a very useful and successful application. So it benefits everyone and it also satisfies my curiosity and learning. Yeah.
Hmm. Wow, so that actually resonated with me pretty well. One reason that I'm still here after about 5.5 years now. This is my 6 years in Pacific Academy, and I still feel like so energized. Even though I do get kind of pissed off by the students, and they all, and sometimes I piss them off. And but overall, this most of the time I'm really into learning new things, even though I have done that for 6 years in a row, but still, there's just so much, right? And that's really it's the one thing that we, what Ted just said, it's just keeping me alive and kicking and feel good to come into the classroom. It's to learn the new subject, right? So that is something that I really enjoy, and because there's so much unknown, right? And I can turn to another subject and then I can just start digging into it, and I feel so
Yeah.
joyful just to learn how it works and then share my knowledge with students, and say it again to myself and making myself actually understood better that it's just such an achievement, to
Mm.
myself. I'm just saying out loud, I mean,
Yeah, I agree with.
I did not come prepared to say what I want to say. I just kind of, look into my heart and say, well, how do I feel, right?
Yeah.
Okay, so I guess the next question would be, how does physics compare to other science, right? To you, why not chemistry? Why not biology? Why is it physics? To
Mm.
you?
Well, personally, biology had used to be like my most like favorite subject, and then when I take physics or took physics, like I kind of changed my mind because compared to other STEM subjects like biology and chemistry, physics is, I feel like, the least required memorization
Mhm.
because everything is pretty, like, it makes sense. Everything has like a logical reasoning. So you barely have to put any effort into memorizing. And since it's like so many, covers so many topics, and each topic you can have like a macro or micro point of view, you can think like in many more aspects. I think you can be way more creative than following some rule given by chemistry or biology. You can become more creative and then talk with peer and teacher to see if your theory are correct or wrong. Yeah, like
Mhm.
that.
I mean, not because I'm a physics teacher, okay? I mean, nothing, I have a good friend, Mr. Rudy. He's teaching biology. To be honest with you, I'm also very excited about chemistry and biology myself. It's
Mm,
just that I
mm,
haven't really done a lot of those kind of study and teaching in that area. But when I was having a chance to teach in physical science, and when I dig into chemistry and biology, they really opened my eyes too. Okay, but I
yeah.
really do agree with you that it does require a little bit more reasoning rather than memorization,
Mm,
and that is a big part of why I like physics.
yeah.
Is because of, does it make sense, right? And
Mm,
every time I don't look at this, I don't look at the books. I just kind of go and taking a shower, or maybe gardening, or maybe taking a walk, or maybe cooking,
mm,
and my brain will be like putting all those concepts together, and kind of like kind of running them back and forth. Say, does that really make sense, right? And when it
mm,
makes sense, it's like feel like whoa, like whoa. It's all of a sudden like you're being occupied by some kind of internal fire or something, and it's just like you couldn't stop. You couldn't
yeah.
stop thinking about it. Just feel like so excited. I need to tell someone about this, right?
Mm,
Like recently, like yesterday or today, I was thinking about like how does ESC and PWM and how does the Hall effect sensor, how do they all work together inside the firmware and the hardware? And I've been like digging the whole day, actually, to be honest with you, like 3, 4 hours. And
oh,
finally, I think there's something actually I did not understand before. And today I was like, oh yeah, I think that's how it works. And that
mm,
really like just like, oh wow, okay, yeah, I think that got to be it, right? And just
yeah.
that's the kind of thing that every single day when I wake up in the morning, and by the end of the day, I just feel different. It's just kind
Mm,
of open my eyes and say, okay, I think it cracked, right? It clicked.
yeah.
And it's just like that is the feeling that I'm
I,
looking
I, I
for.
want,
Go
I
ahead.
would like to add one thing. It's like when I had a favorite subject in biology, specific topic has to do with like the brain. And I read numerous like scholarly article online about, oh, how can we stimulate the brain? And then I always found it ties back to physics and EM waves to stimulate like within the brain non-invasively. So that's why I keep like everything that I find having to do with the nervous system and devices is always keep tying back to physics. And I always want to learn how does it work? How can I improve those devices and such stuff like that?
Yeah. It's funny you say that, right? Because when I was looking at biology this semester, I actually check into neuron, right?
Mm,
So they have those synapse fire, right?
yeah.
And I realized it's like a 30 nanometer, right? The gap, and then they have kind of like a chemical type of transmission in
Mm,
within the neuron, and then in between, it's I forgot. I think it's physical, right? It's physics type of neuron fire,
yeah.
right? And
Yeah.
and indeed, I mean, in our body, like gravity play a big role, and then the force, like intermolecular force, the EM force, right, really play a big role in chemistry and biology. Not so much the nuclear force or the weak force, but whenever you go deeper into what's really supporting what's happening, then you realize that it's physics that playing that carrying that rock, right?
Yeah.
That rock, and so that you can actually understand. And then the EM wave, it's everywhere, right? So you understand EM wave, and you realize the EM wave and electron are actually like back to back, right? And the electron is the one that also influences the magnetism. And so by the time you really understand the EM wave thoroughly, you realize the whole world is centering around EM wave.
Mm-hmm.
It's not a joke, right? I mean, I
Yeah.
really haven't come to a stage that I feel like, oh, I really understood physics. Like I really understood it, right? I haven't really come to that stage, right? Because I feel like, well, why Einstein can actually understand relativity,
Mm.
right? How come he can figure it out, and how come I still can't understand what he is saying, right? I mean, I haven't really studied relativity that seriously yet, right? Maybe if I study, I would be able to, but when I'm thinking, I think he probably were able to put his mind into the black hole, and then
Mm.
put it in there for half an hour or 1 hour or 3 days, and then bring himself out again, right? So that's just the power of brain when you can, like basically kind of like separate your brain, your thinking away from your body, and it's just travel into the universe, and
Mm.
then just like and then you experience all this different kind of feel and the force, and in the space and the time and then blah blah blah, right? And equations and all those knowledge all gel together, and then all of a sudden you say bingo. That is the concept. When you really understand it, I bet it's actually quite simple, right? But I don't think I'm
Yeah.
in that stage. But I wanted to be like that, but I don't think if I ever get that, maybe I will, maybe I don't, right? Anyway, we cannot get a little bit out of away from our original subject. Okay. So the next question is, so how about AP physics in general? What subject have you learned that really excites you in terms of the last 1.5 years? Like, like, oh, I learned that, and that really like, oh, just like crack me up.
Mm. Well, recently,
One thing, right?
for
Could be
recently
one,
or for AP
anything,
Physics 1?
anything, right?
Oh,
Anything,
I
right?
think eddy current has been like the most interesting to me and how it's used for braking. Um, and it's a slightly difficult, I like for me to understand, which is why I like to think about it more. But I couldn't believe that, oh, there's these kind of circular pathway that electron are traveling in. I never even thought that something like this is possible. And that is somehow making the metal like break without any contact at all. That's what, yeah, definitely was the most interesting to me.
And that day, I remember you and Jason were there, right?
Yeah.
Talking about eddy current, right?
Yeah.
We're going onto the whiteboard, and we start drawing, right? And then I
Yeah.
asked you to give a lecture, and then I asked Jason to give a lecture, and then yeah, I still remember that
Yeah.
your lecture. But keep in mind, eddy current is probably something that not everybody, our audience may not know what eddy
Mm,
current is, right?
mm, mm.
Uh, you want to like quickly describe what eddy current in simple terms?
Well, it's kind of like in the metal, there is some free electron that can move in a circular path. And if you consider there's always moving in that circular path, uh, you then there will be a certain flux, which flux is when that kind of loop enters into a magnetic field, and magnetic field is produced by two permanent magnets like a north and south pole. And so there's some other laws like Lenz's law, which kind of try to stop the change in flux, means try to stop the like amount of magnetic field that's going through the given area. So then to stop that, there will be a force to kind of stop the eddy current from entering into the magnetic field. So that's what's causing the like opposite force to break. Yeah, kind of like that.
So basically, right, magnetic induction.
Yeah.
Lenz's law.
Yeah, Lenz's law.
The creative part is that the electron knows where to find the path within the metal.
Yeah.
Right? Okay. Anyway, so we always need to find a simple way to put the concept and then try to break it down for the student so the student can actually appreciate.
Yeah.
Because when you start teaching, I really didn't teach before, and I realized that okay, I don't know how to explain that to student, right? So every day, when I feel that I can grow is when I know how to explain things. It's not so much whether I understand it. I mean, you do become more understanding, having more understanding when you know how to explain it. But actually, how to explain with the kind of words and how to break it down in pieces so the student can follow that, in the beginning, and then give them another piece and then another piece. And then once you do that, then they appreciate it. And that's when they feel excited. And then they can grow their energy.
Yeah.
But to me, actually, what I find the most interesting was the quantum mechanics. And when I say that, it's like the guitar's wave, right? So the guitar string, when it vibrate, it has this different kind of harmonics, right? And that harmonics actually tie into how the electron circulate the orbits inside our atoms, inside our bodies, right? And it also have this different orbits, and the different orbits is actually very analogous to what guitar is playing. And also when the electron is circulating, it creates this angular momentum, and then when you accelerate electron, then it can actually generate EM wave, and then the electron become the lights, and the light can also become back to electron. Electron also play the role in creating the magnetism, and electricity is the magnetism. Magnetism is the light. And it's just like, the whole human body in the whole universe is just really just EM wave. It's constructed of EM wave. It's actually constructed as neutrons, right? If you put everything together, it gets really, really like, oh man, what's that? Just a very powerful. I mean, to me, that's really powerful. Okay. So we're gonna continue what we were talking about. So how about among AP Physics 1, right? What is AP Physics 1, in 1 minute? What would you say? What's AP Physics 1? Well, we know it's mechanics, right? So what is it, in your opinion?
Like, and for me, in more of an abstract way, I kind of feel like there's a lot of things in real life, physical occurrence that we kind of take for granted and just like, oh, this is how something should happen naturally. But when we look at AP Physics 1, we get a like deeper understanding and like the direct relationships, like maybe, oh, is it related to a square root or 1 over some variable square, something like this. And oftentimes I find in real life, I saw like, for an instance, when you swing a ball with a rope, what is like the trajectory when you cut the rope? Initially, I was thinking, oh, it might follow the circular path for a little bit after it was cut. It's kind of illogical now that I look at it from physics 1 perspective, because of course string needs to be connected to still exert force. And so it's a lot of things like this that also with friction that you don't really realize like how all the components get divided and such stuff like this. I think it could just give me a better feeling and think about new things in real life that I didn't usually think that deeply about. Something like that.
Yeah, so Tej is quite good at describing his feelings, and I have been struck by how how he's able to picture what his doubts is, and what other people's feeling is. I can definitely see as a young person, and he's quick at that. So my answer to what I just asked my Tej is that to me, physics is a model, right? So you have real life, but when you study physics, you basically are having a construction of model so that you can actually apply mathematics and you can simplify that real life into something that you can actually study, and then that study then give you some analytic tool, and then you can graph it, and then you can kind of like doing the inference, right? Inference, right? You can then
Inference.
kind of step one to B and A to B, then B to C, then A to C, and if it's not A, then it's what, right? So those kind of logic can then come into play. So that's, to me, that's what physics about in AP Phys 1 or AP Phys 2, right? So you are constructing this model. And then in AP Phys 1 in particular, you're basically learning how a rigid body works, okay, in terms of the force, in terms of energy, in terms of momentum, right? And when you study that for the 1 point mass, and later you go into the rotation, then you all of a sudden you have this 3D object. Then you studying the 3D object and you do all that concept one more time. The kinematics, right? The velocity acceleration, and then the second law, then the energy and momentum, and then the UCM, and then the one more time, right? So basically that's what it's about, is mechanics, but for rigid body, and it's for point mass, and then for 3D, right? And then you're looking at the conservative law, right? Conservation of energy, conservation of momentum, conservation of angular momentum, and conservation of charges, and conservation of mass. And then you're also looking at the F equal to ma, the Newton's second law and the third law. Well, actually, second law including the first and third law, right? So that is what that is.
Yeah.
So we only have about 8 minutes left. Let's switch our gear into AP Physics 2. Okay. So if you have just 1 minute, right, or 2 minutes, and you want to like explain that to your grandma, what is AP Physics 2, right? Because we got about 18 chapters.
Yeah.
AP Physics 2. We probably have about like 7 or 8 subjects, and each subject could have 1 chapter, could have 3 chapters, could have 4 chapters, right? But basically, you have about 8 subjects or 18 chapters. So in 1 minute, what is AP Physics 2 like to you, right? You learn all the subject already, right?
Yeah.
So what do you think? Like,
To me, like I see three main division. Some of the first like division have to do with like, of course, everything's physical, but it's kind of a macro view having to do with like heat. And there was some section about expansion of material with some temperature and the heat. And then the second portion I would look at is kind of maybe and also I would add in the first portion is like PV equal to nRT, which is ideal gas law. It's another kind of macro view generally. And then the second portion to me is more about the circuits and stuff like Ohm's law, which is V equal to IR, and other things to do with circuit. And then I think the third and last one is more focusing with waves. And how different waves like work, EM wave or electromagnetic wave or mechanical wave, and yeah, stuff like these are the three main divisions that I see. And one more section is like the lenses and light and how they diffract or refract. And that one I would also place into the first category for like kind of physical, larger scale kind of things. Yeah.
yeah. Well, that's pretty good. If you ask me the same question, because it included all the subject that you would study when you go to college. If you study physics, you study mechanical, or you study electrical, it's probably going to be 60 or 70% of physics will be, like entirely physics, 100% will be in physics, right? There's so many different kind of material, right? So you can divide it into like, if it's for fluid, then it'll be like, fluid dynamics will be gas and liquid, right? It doesn't
Yeah.
talk as much about solid.
mm,
If you come to heat transfer and thermodynamics, it's so much more about gas now, right? Now, if you
mm,
go to electricity, now you're looking at not so much gas or fluid. You're now looking at some kind of funny devices which can actually let the electron find a
mm,
path. And then that electron, when it flow, then it can be an electric fan, it can be a TV, and it can be a phone, and it can be, many different things, right? So
mm.
it's not heat transfer, but when it runs, it definitely generates heat, right?
Yeah,
It
yeah.
runs when it has heat, then it will influence how the gas will flow, then we'll have fluid dynamics also, right?
Mm,
And
mm,
then you start looking at, say, the lens, the optics, but that's really EM wave. But we
mm.
know EM wave is electrons. So
Yeah.
electrons inside the electricity field, right?
Mm,
So then,
yes.
you can see that EM wave all of a sudden is also related to the electrons, right?
Yeah,
And
yeah.
then now it's more about how to use the light to help us to see something or
Mm,
to put it on the walls, right? Or to put it on the screen or to put it on Google Glass or put it on Apple Watch, right? So or put it on anywhere like inside the noon, right? So it's about lights now, right? And then when
yeah.
they go to the light, all of a sudden you see it open up another big door. It's the EM wave, and you have
Mm,
all this EM wave spectrum, and you have all this different kind of phenomena that come into the quantum mechanics, right?
mm,
And then all of a sudden, when you start digging and digging like further down into the smaller scale, you see the nuclear physics, you see the subatomic, type of particle, right? And then you have the new subject, and then you have the decay and all that stuff, right?
mm.
And then you also have magnetism, which is just another like a mirror of the electricity, right?
Yeah.
So that's kind of like link them together, not in a very nice way, but it does kind of linking them
Mm,
together. Okay. We have only about 2 minutes left, and I think it's been a very enjoyable, type of discussion with my own student. This is the first time we ever talk, right?
yeah, yes.
We did kind of talk before the interview for about 5 minutes or so.
Yeah,
We
yeah.
just kind of get to it, right? We
Yeah,
didn't
yeah.
really try to like stage or act, just like be ourselves. And
Mm.
so we have about 1 minute for you. If there's something that you want to kind of like encourage the freshman or maybe middle school student to come and yeah, come and study this. This is exciting.
Mm.
We're doing the project, we're doing drones, we're doing just different things. What would you say to them and say, yeah, you as a young people, you should come and learn more about this and why,
Yeah.
even though it's hard work, right? A lot of very intense work. Like, go ahead.
So I will say that for me, and I think for most people who will take physics, it's completely different from any other subject in school in the ways that it kind of opens your mind, and you have to be flexible and not stubborn and be open to like new ideas and being wrong and admitting you're wrong. And this is teaching many other life skills at the same time. And like as a whole, it teaches you how to be a good and strong critical thinker, and how to also help yourself at time or help other people or even ask for help. So physics is interesting. That's one side, satisfying yourself, but it has a lot of application in real life and to understand the world much better. So there's no reason I feel like that you should avoid physics. There's no reason at all because it applies to absolutely everything that you have in your life. The hard work is only a small pain, I guess you could say, but it is definitely worth it once you've learned the concept and you can get the satisfaction at the end. Yeah.
Mm. Well, Tej is quite a philosopher, okay? So he know how to think and how to ask question, how to answer question, and how to admit when he's making a mistake, and he's not afraid of making mistake and admitting that he doesn't know, right? And I think that is definitely one thing that I think if you want to study physics, you should not be afraid of saying things that it could be wrong, right? or you should also be humble to say that I really don't know this, right? So I'm here to study, I'm here to learn, and I'm here to make mistake, right? I'm not here to hide, I'm not here to pretend I know. I think we're running out of time, and I think that's a really good place to end our show. And thank you for watching American College Dream, and we're here to support our student to be ready for college and to learn in life. Well, thank you, Tej. That's the ending of our program, and thanks for coming to the show. I'll see you in class tomorrow.